Welcome everybody to part 4 of our Humanitarian Applications Using NASA Earth Observations RSET webinar. Today we are talking about assessing climate hazards at refugee camps. And as you recall from the previous parts, we've gone over the arc of different kinds of humanitarian applications in the context of armed conflict and displacement. So we started with monitoring urban damage with INSAR last week. Then we moved towards mapping refugee settlement growth and population change, and then agricultural and vegetation change. And so today we're sort of at the other end of the spectrum, thinking about conditions at the location, sort of exogenous conditions at refugee settlement locations, and also thinking about more of a long-term habitation, recurrent risk, sort of persistent hazards at refugee camps. So we're here on part 4 today. Just like all the other sessions, this will be about 2 hours long, and that will include a question and answer session at the conclusion. So feel free to be entering your questions into the chat box as we go forward, and we'll collect those and then answer them at the end of the presentation. So this presentation is really motivated from the fact that we have new refugee settlements established in new locations. A settlement is often created in sometimes a remote or borderland region. In some cases, there aren't other human settlements in the sort of direct proximity. So with that new location, we have new kinds of climate hazards that large populations hadn't been exposed to before. So there's sort of new considerations and scenarios that haven't been examined or certainly not analyzed from a research perspective. We have a lot of new data, of course, from satellite and other sources to study climate-driven events and hazards, but that data doesn't always mean it's going to be used appropriately or effectively, and it may not be used at all. This part of the training is trying to leverage the available data we have from satellites and other sources to start estimating climate and environmental exposure in a sort of a systematic way, such that we can take the same kind of assessment site after site after site, and certainly country after country, in an attempt to aid a more systematic examination of climate hazards at refugee camps. So our goals today will be using a multi-criteria hazard analysis to estimate climate hazard potential across multiple sites focused in a refugee hosting region of Bangladesh. We'll be looking at how these different products influence our assessment, different satellite products influence our assessment, and we'll be looking a little bit at how climate hazard profiles compare to some of these known hazard events. As a reminder, there will be one homework assignment for this webinar series that will be posted on the training page. It'll be due July 7th, and completing that homework assignment is part of the certificate of completion for this webinar. You are expected to attend all the webinars and complete the homework assignment by that deadline, and submission of that will warrant a certificate, which you'll receive about 2 months after the completion of the course. So information on this slide as well as on the training page. My name is Jamin Vandernook. I'm an associate professor of geography at Oregon State University. I've been speaking thus far. With me presenting today are Andrew and Michael, both of whom who have been involved in different kinds of climate change and climate hazard analyses in kind of different contexts around the world. So we'll be hearing from them later in the presentation. As a reminder, we have a few previous RSET trainings that we could recommend for thinking about sort of preparing for some of the themes and topics we'll be talking about today. One is SAR for disasters and hydrological applications. We aren't going to be using SAR directly, but certainly for this sort of context of disasters and hydrological applications, that's a good training. We have Earth observations for disaster risk assessment and resilience, and remote sensing for disasters scenarios. So check those out. They will provide a good bit of precedence before we enter today's topics. So let's do a little bit of background on mapping environment and climate exposure in Cox's Bazar in Bangladesh. So from a global perspective, we know that refugee camps are exposed to climate hazards, such as landslides, flooding, droughts, and heat waves. There are, of course, as we've talked about in previous parts of this training, we have a global distribution of refugee camps and refugee settlements around the world. Many of these settlements have non-durable dwellings, so dwellings that are sort of ephemeral or temporary, or constructed without any formal safety or sort of protocols that would help protect against or mitigate the effect of landslides, flooding, things like this. We also know that camps are placed often in isolated and marginal borderlands. This sort of general setting, both at the dwelling as well as the regional area, can contribute to some of the climate exposure that we'll be talking about today. And as we've touched on in other parts of this training, the refugees themselves are also made vulnerable socially from restrictive migration as well as communication policies. So there may not be a lot of climate hazard information coming into the camp in terms of early warnings. And there may also not be very supportive migration policies to allow refugees to leave with a pending hazard in the same way that others living outside of the refugee camp might be able to flee in advance. We have one example here, a picture on the left showing flooding in Cox's Bazar refugee camp from 2017. We'll be talking about Cox's Bazar later in the presentation, but this is really one of the epicenters of awareness, at least in terms of climate hazard exposure in a refugee setting, because it's been affected many, many times in quite large scale way. Now we know that Cox's Bazar has been affected. We know that there are certainly other cases, other camps that have been affected by climate hazards. However, there's little research on environmental and climate hazards at refugee camps. A lot of the stories, a lot of the evidence we have are sort of one-offs. They're, we could call them as anecdotal evidence, which isn't a diminishment of the value of the evidence, but it's a reflection of the fact that we don't have a systematic assessment. It's localized here, it's localized here, one event. We don't have right now a real systematic assessment across multiple refugee sites across decades, for example. But we have lots of single lines of evidence that show that this is a phenomenon we need to be concerned about. In 2006, for example, heavy rains flooded the Dadaab refugee camp complex in northeastern Kenya. It was a deadly flooding event. 2 people were killed. About 13,000 people's homes were lost. 2017, the same camp, Dadaab, was affected by another flood. In this case, 63,000 refugees were directly affected. And nearby, in 2014, the Liukior refugee camp in Ethiopia was flooded. Here's a picture of it on the left. It basically forced the relocation of 40,000 refugees. So these are serious challenges when we have already scarce availability of resources, often, again, remote isolated areas, perhaps not great connectivity to infrastructure or aid delivery or, evacuation routes, right? So this can be an acute challenge in already resource-strapped areas. Flooding at Cox's Bazar has perhaps received the most attention. There have been a series of flash floods. This is the kind of higher impact, higher magnitude flood events that we know about: 1988, 92, 98, 2012, 2015, and 2021. So already we're going back about over a 30-year record there from 88 to 2021. We know in 2021, this most recent large-scale flooding event, that 8 people were killed, 21,000 people were displaced. Again, this is a recurrent challenge within this area. The floodwaters can go to chest high on an adult and go over the heads of young children, 1 to 2 meters. The water could be a flash event, lingering for several hours, or could last an entire day. There's also serious contribution to increased landslide potential, which can also be deadly and can also wash away homes and roads. The flooding and the landslides can also destroy terraces and crops, so the livelihood implications or food security implications can be severe as well. So there's really a multidimensional phenomenon, a multidimensional danger coming from these different flood events. We also have the great concern of just the sheer population density across Cox's Bazar. 1.2 million Rohingya refugees are distributed across 34 different camps in this region called Cox's Bazar. The population in general, the refugee population in general, has been there a long time, since the 1970s. However, it was this 2017 arrival of over half of the current population, 700,000 refugees, that led to the kind of phenomenon we see on the right-hand side here with right about now in the animation, where this large-scale deforestation and land clearing that took place to establish new terraces and dwellings for the incoming Rohingya refugee who were fleeing violence and persecution in neighboring Myanmar. These flooding events now come mainly in the summertime, northern hemisphere summertime, June and August, and there's about an average of 1.6 meters of rain that falls within these months, June, July, and August, looking at the historical average. So it's a lot of rain over a short period of time in a landscape that is often exposed with bare soil due to the terracing, and so that land use as well contributes to increased landslide potential. As mentioned, the policies themselves can also, refugee policies can compound the mitigation of these events. We know that voluntary migration is a key strategic decision to mitigate climate effects. People, when they can, they leave, right? If there's a pending danger, and we know that higher temperatures and rainfall extremes drive out migration in other parts of the world. In Cox's Bazar and in many other refugee settings, that kind of voluntary migration is restricted by asylum policies that confine refugees to refugee camps, not just during the climate hazard prone period, but throughout the year and over many, many years. There's this restriction on migration that basically keeps refugees in place, even though we know that an extreme event may be coming. So there's sort of this need to prepare and to anticipate these events so that we can build some mitigative potential, since one of the key opportunities, migration, is not there. So that's one of the motivations for our training today, is building up this awareness through quantitative use of satellite data and derived products to better assess likelihood of climate and environmental exposure. That's a present concern. But of course, we know that future climate change effects, such as more rainfall and higher temperatures in Bangladesh and other refugee hosting countries, are going to make these challenges, probably not always, but in many cases, will make them more acute, will make them more severe and more frequent. So we have this increased likelihood of even more climate hazard exposure as climate change advances, as we can see here with these maps on the top register of mean annual surface temperature increases by about mid-century, and a change in annual precipitation by about mid-century. In both cases, we see this, of course, global distribution, but these changes that we're seeing are going to play out differently in different contexts, and of course, compound existing hazards and risks. So in a refugee setting, understanding climate risk is not just thinking about how erratic is the rainfall, how much rainfall do we get. It really is a refugee setting as well as anywhere else. We want to think about this from multiple perspectives. It's not just weather and climate. We want to think about the social vulnerability. We want to think about the likelihood of exposure. So that's in the refugee setting, would be thinking about the kinds of dwellings, the kind of infrastructure that's there. And on top of that, of course, we have this background fairly low adaptive capacity, which is to say the resources that are needed to adjust or respond to these actual or expected climate effects We have a marginalized, economically marginalized, societally marginalized, and geographically marginalized communities that are affected by similar kinds of climate hazards that other communities are affected by, but they don't have the resources to respond, and they're restricted due to these various policies that I've mentioned prior. So it's not just, we're not, in this presentation, we are just focused on the climate and weather side of things, but the bigger picture is much more complicated than that. So with that, I'm going to hand it over to Andrew, who's going to walk through some of our case study on environmental and climate exposure at Cox's Bazar.
Thanks, Jamin. My name is Andrew Kruczkiewicz, and I'll be taking everyone through the second part of this training. We're going to be diving into a specific case study. So building off what Jamin was saying in terms of the different ingredients, really, to understand risk. What do we mean by that? What do we mean by the climate environmental factors, the social factors? You know, these are important ingredients when we're trying to get a sense of what it is like on the ground. And this is important in any context, as Jamin said, but in particular for areas that are more complex in socioeconomic settings, such as refugee camps. So I'm going to be sharing an example that is one that's very close to me. About, it must be 5 years now, I was working with some UN organizations. One in specific was called the Interagency Standing Committee, which is a group at UN headquarters here in New York that seeks to coordinate a lot of the disaster and climate activities of the UN and other activities, primarily humanitarian activities. And during that time, there were questions about, well, we're developing standards and methods for integrating climate information into decision making, but we actually have a situation happening right now, you know. And this was back in 2017 at one of the most recent, let's say, movements of population from Myanmar to Bangladesh. And they said, well, this is something that's happening now. And if we're thinking about what data sets we could use, you know, when do we integrate these data sets? What are the decisions that could be impacted? Where is the responsibility? You know, who is accountable for integrating data into decision making? They said, well, there's something happening now and we need to address that. And this is referring to the Rohingya refugee crisis. And they asked myself and a few colleagues to make a couple of visits over the next year or so to support this. So I'll be telling a little bit more. I'll be sharing some pictures about or from the area around Cox's Bazar and in around Cox's Bazar to talk about, you know, what did we do when we had to identify which data is sufficient to integrate into decision making in a very complex situation. So we decided to start off with this picture here. And this is a picture taken, well, the next set of photos were taken by myself and a colleague, Melody Brown, who were part of the team that was tasked to think about what types of data can be integrated into disaster risk reduction as they were building the refugee camp in Cox's Bazar, the refugee camps, I should say, and what types of hazards should be prioritized. And this was from one of the first days where we were working with IOM, International Organization for Migration, and UNDP, the UN Development Program, as well as with World Food Program and UNHCR. And we were getting familiarized with the setting. And this is from one of the tops of the hills of the refugee camp, Camp 10, as you see in the flag. And this is a snapshot of what it looked like at the peak of the dry season. This was March 2018 this was. And there's a lot of talk about the rainy season is coming. And in the rainy season in Bangladesh, there is significant and prolonged heavy rainfall for months. And there was a rush to get an idea of which data should be used, which areas could be prioritized, who would be impacted, and yeah, essentially, how do we prioritize and what actions can we take? So this is just an overview of the setting. And as you can see here, there's many housing units. Many of them don't have very strong roofs, and many of them have cloths in terms of kind of covering the houses and the doorways and the windows. Something you cannot quite see here, but I'll point out, if you look at the center left, you see some blue structures. Those are latrines, which are right up against the hillside on some very steep slopes. Other things to note here, you will see some greenery, very little greenery, but this area used to be one of Bangladesh's last dense forest area. So you could maybe get a sense of all the trees that were cut down, which also led to a change in the topography and also many of the other environmental and hydrologic conditions in this area. Here's another picture, and again, this is a picture taken at the peak of the dry season, the hottest time of the year, right before the rainy season starts, and there's a few things to point out. Actually, I think what I'll do is wait 10 seconds and have everybody think about, like, what are some of the elements that point out here, that stand out to you here. So I'll give it 10 seconds. Think about, look closely. What do you see? What's going on in this picture? Give you 10 seconds. Okay, wrapping up. So there's a few things to highlight, and I hope that even things I don't mention, you'll have other things to highlight. I'm interested in hearing what you're thinking about. But again, yes, you see some of those blue structures, those latrines on the steep slopes. They're here again. You also see there's people doing things. There's people moving about. You know, I don't know if anyone here has been in a refugee camp or seen a refugee camp, but there's a lot of activity. You know, this isn't a place where people just sit in the houses. Like this is a place where things happen. People are moving. There's movement in this image. Something else to note: there is standing water already. Like, we're talking about the end of the dry season, the peak of the dry season. There's already standing water. So there was a lot of questions around what flood mapping products, what does flood risk mean when there's already areas that are somewhat inundated? And that was a very difficult question to address, because, yeah, what does it mean? Like, if we're talking about which areas are going to flood, what does it mean they're going to flood, like, from this source and kind of expand outwards? Was this body of water connected to some sort of river or stream system? There's many questions. Another thing to point out here is, if you look at the top left of that hill in the background, you will see one tree. And this is something that still kind of sticks out to me. It sticks in my memory, this one tree. And to this day, I don't know why they left that tree, but it's a reminder of how tall the trees used to be, how dense that forest could be. It's hard to imagine this area covered by forest and what it would look like to have that kind of thriving sense to this land. But that was the size, that was the height of the trees that existed in this area before the decision was made to build the camp here. And I should also note that this is just one of many refugee camps in Cox's Bazar. This is a picture from Kutupalong, which also known as the mega camp, and I believe approximately 700,000 or 800,000 refugees live in. But there are many other refugee camps that look very different from here that we'll also talk about a bit later. So as you can see here, what are we looking at here? So this is a satellite image of the mega camp, Kutupalong, and you could see almost like, let's say, they look like kind of streams almost, but those are areas, lines of topography in some ways that separate some of the sub camps from other sub camps. And we could see the patterns emerge here of different housing units, you know, that are placed in areas that, in order to maximize the amount of people that could be sheltered. And it makes us think about, like, why was this area prioritized? You know, what are the decisions that go into selecting this part of Bangladesh? And there's many reasons for that. You know, it's not a straightforward answer, but for whatever reason, this is the area that they picked, and this refugee camp was expanding very rapidly back in 2017, 2018, as you can see. And here's another picture. And I know we're spending time sharing pictures here, but I think it's important to get a sense of the setting. One thing that we acknowledge is if you're interested in working not only in refugee camps, but migration settings and other complex socioeconomic contexts, is a very privileged place to be, to even discuss what risk means, in the context of the most vulnerable populations. And I think this picture reminds at least myself to reflect on that. This is the main road that transects the mega camp Kutupalong, and it evokes to me at least a sense of not only the intensity of the camp, but also the depth. It seems like the camp goes on for a very long time if you look in the distance. And I think that's an important element of this. We are Earth scientists. We are satellite data, like Earth observation data scientists, but we're also people. And it's our responsibility to keep that in mind when we are thinking about what it means to integrate satellite data or any data into decision making. So I think that was important to say before we move forward. So going back to this picture about what that had the body of water in the foreground there, our job in supporting the disaster risk reduction strategy in the refugee camp was not necessarily about developing new forecasts or new data sets or new systems or tools or interfaces or apps. It's actually most responsible to make sure you know what is available first before the reaction, before you react by developing something new, which will have implications on how decisions are made. So after various discussions and meetings, we realized that there's actually 3 primary questions that they were interested in that time that they asked us to support. And those are the 3 in the top left. Where can floods occur? What type of floods? And then where can landslides occur? So these are questions related to hydrometeorological extreme events. There were questions around like, will rainfall forecasts be sufficient if we're trying to understand risk? Can we disaggregate, within a refugee camp, areas that are at relatively higher or lower risk? If we prioritize one area of the refugee camp, maybe 200,000 people over another, what does it mean to deprioritize the remaining people who may not receive the benefit of an early warning system or some sort of early action? These are critical questions to remember. And yeah, it's when you're thinking about prioritizing a group or benefiting one group over another, not only refugee camp, but more broadly, you're also contributing to a decision to deprioritize some other group of people. So what do you do when everyone is the most vulnerable? And that was one of the questions that still haunts us to this day. When you have data that allows you to distinguish between the most vulnerable population and the least vulnerable population, if there is significant distance between those two, perhaps it's justifiable, but what do you do when everyone is the most vulnerable? And that is a very complex question, but one we're faced with when we're thinking about refugee camp management. These are the most vulnerable in a global perspective. So again, like thinking about the hazards, well, I mean, this area, Cox's Bazar in Southeast Bangladesh, is a climate shock prone area. And what we mean by that is this isn't a new thing. Like there's a history of floods. There's a history of coastal flooding. There's a history of riverine flooding. There's a history of flash flooding, pluvial flooding. There's a history of the historical data shows this is an area, the Bay of Bengal, that has frequent tropical cyclones, and these are there. Fortunately, there's data available to help us understand the risk of the past and up to the present. But this is a situation that is a protracted crisis. The Rohingya refugee crisis is not something that has happened in the past 5 or 6 years. It's been going on for over 20 years in different waves, in different cycles. And we were very much thinking about not only the historical disaster risk, but also what's happening now and how that might change in the future. But yes, I mean, so what do you do? Like, if there's an understanding of the historical risk of disasters, there's the understanding that that might change in the future. But what can we do? We must do something. Action can be taken if risk is understood. And if you do develop standard operating procedures, if there is a shift in risk, then there is a potential to prioritize one area over another. And that was one of the goals of our work, which was funded by NASA as part of a project we called COMPAS, that led to a workshop in which the report on the right-hand side was produced. Use of climate and risk information in the Rohingya refugee response. And this is freely available, and happy to send this for an even deeper dive into what data we used, what decisions were influenced, and also an interesting section on using a process called the decision-making flowcharts, which allow us to outline which questions are being asked related to disaster risk reduction, what data is currently being used, and then what data is available and could potentially complement the existing data being used, or perhaps should actually be prioritized over the existing data. Of course, what comes into this discussion is the idea of mandates and roles and responsibilities of producing data, disseminating data, tailoring the data. This is all, these are all important elements of that chain, from developing, let's say, producing data all the way through to what we call like decision making and taking action. So there's more information in that report. And yes, thinking about data that's available, I mean, official and authoritative data does exist. And we found that in Cox's Bazar. On the left-hand side, this was a UNHCR produced map of flood risk area in the mega camp Kutupalong. In the top right, this is a screenshot from the Bangladesh Meteorological Department. This is the numerical weather prediction product, which helps us get a sense of rainfall and intensity of rainfall. And in the bottom right, this is a modeled flood hazard map for the various camps, not just Kutupalong in the top left of that bottom image, but the other refugee camps as well. So the products existed. Like, there was definitely, this was not an instance where we needed to develop something new necessarily. It is our responsibility to understand what is already in existence. Is this data trusted? What are the mandates, political mandates of using these data? And then this idea of like, well, let's just blend them together. You know, like many times that's an answer for this. Well, there's many data sets. Let's just we'll blend them together. Well, I mean, which one takes priority? How do you weight this blending? Like, how do you actually do the blending? Like, many times they're on different spatial scales. These are all questions that need to be addressed. But wait, there's more. There's more options. It wasn't just those products. There were many flood products that were already produced. So this was interesting and stressful, because why was there a need for us to be hosted by the Intersector Coordination Group in Cox's Bazar, which is in charge with developing many of the disaster resilience plans? Why did they need advice and support and guidance on which to use and how to integrate these in decision making? And one of the answers is, well, that's a skill in itself, being able to understand how to tailor the available data into something useful. You know, so a lot of the work in this context was actually was saying, all right, like, this is a complex space. What data products are available? Do we understand the quality? To what extent do these need to be used or acknowledged as part of the mandates in the area? So yeah, here's another set of products that were available. And yeah, all of these come from, let's say, official and or authoritative sources, but it's hard to blend them together. It's hard to know exactly how to prioritize them. So we came to the case of, well, there's too much data and not enough time. Yes, that is a question you should ask. How is one prioritized over another? How is one deprioritized over another? I know that may seem like the same thing as the previous question, but they're, on one hand, they are similar, or at least complementary, but the framing demands a different process to navigate the responsibility and accountability for those. It feels better on a personal level and also professional level to say, we're prioritizing this data and therefore it'll help this group of people. That feels much better than saying, well, you know what, we're going to prioritize this data source, and sorry, this community over here, this data says that you don't receive benefit. You're at risk, but not at a sufficient level of risk. So sorry. And it makes things much harder when you look at it that way. But in reality, if you're going to claim a data-driven process or a data, let's say, supported process, that question will arise. Like, if you want your product and process to be sustainable, you're going to have to think about how to address that. And that speaks to the last question there as well about prioritization and deprioritization. So we're just going to go through a little bit more of the refugee camps, the different camps here. So the different camps were subject to different types of hazards. If you look at the northernmost camp here that is circled in the red, Kutupalong, that's the mega camp. This is an inland camp in an area of relatively complex topography. It is subject to riverine and flash floods. You'll see it is not near the coastline, over 10 kilometers from the coastline. Therefore, coastal flooding is zero. There is no risk of coastal flooding in this area. However, Nayapara and surrounding camps are actually at risk to various types of floods: flash, riverine, and coastal. It's kind of hard to see here, but actually the eastern side there is the Naf River, and that area is one of the areas where the churning of the cyclones sometimes pushes seawater up to the eastern side of those camps, Nayapara camp and the other ones. So there is all three types of risks here. So when we're talking about flood, developing a flood risk reduction plan, which type of flood are we referring to? And then Camp 23 here is primarily at risk of coastal flood. It's on the coastal plain and is right on the coastline. Flash floods, yes, there is a low risk. Riverine floods, no, because there's only very small streams flowing through here. But the main takeaway of this section here is that, yes, many times it is the situation in Bangladesh is generalized to say the refugee camp, or these are the hazards. But actually, when we're talking about populations, there are thousands of people, refugees, in each of these camps. So we need to be sure that we're developing these strategies that are specific to the needs and the risks present in each camp. And as you can see, if you look at the 4-kilometer scale on the bottom left, this is a fairly narrow and long area. And the risk does change over geographic geographic extent as you move north to south. And then going back to the social variability as well, it is complex. Kutupalong camp is mainly new arrivals. So that was that very large wave of people moving in 2017 and 18 to Kutupalong. But other camps have had refugees living for many years. And there's a different dynamic with the local communities, relationship with the land, with the place. And these are also elements that must be accounted for, because when we're talking about disasters, we're not just talking about the extreme climate event. We're talking about those ingredients, the extreme event plus the social context as well. That's what makes a disaster. You don't have natural disasters, really. That word is actually not used very often because the hazard may be natural to some extent. However, the combination of the social context and the policies with that extreme event is really what leads to the disaster. So the humanitarian decision-making process is a complex system. And it consists of, especially when we're talking about climate hazards, we will focus on generating a composite index of environmental and climatic exposure that reflects some considerations that goes into that humanitarian decision-making process. We can't say that what the single most important factor may be, or necessarily say what the best data are, but we compromise here, and the point is we're always compromising. We're always making decisions, and understanding that agency to compromise and make decisions is also part of understanding your privilege and your responsibility to interact in this space. So I'm going to hand this over to Michael Owen, and he's going to be talking a little bit more about these 7 steps that you see here on the screen. So yes, thank you all for listening to this section, and over to you, Michael.
Thank you, Andrew. As Andrew had mentioned, my name is Michael Owen, and I'll be taking you through the rest of the tutorial, which will now be about the actual exposure index construction. And so this tutorial will include 7 key steps. We'll go over data access and pre-processing. We'll go over kind of an overview of our full methodology, how we go about selecting variables and what those variables are, and then looking a little bit more in depth in terms of the study location, how we calculate the index, and then results. And we'll switch between this slide deck and then also kind of a Colab notebook. We'll go over some actual code. So all of our data access and kind of pre-processing is using Google Earth Engine. And we're using a Google Colab notebook, which is essentially just a Jupyter notebook, to actually perform some of this processing. And in addition to Earth Engine, we're using a set of a couple other kind of simplified packages, Python packages, to help aid us through the process. And so because some of the actual index construction is quite time consuming in terms of actual processing, what we've done is actually pre-processed much of the data, which you'll see on slide 43, to allow us to actually quickly go through the information. But we've provided that supplemental code and can go over that so that you can go in your own leisure to actually process and generate additional indices. So as we've referenced before, we'll be walking through one potential methodology for indexing environmental and climatic exposure. And so we are going to follow essentially a 6-step process to calculate the index. And so this is our high-level overview of the steps that we'll be taking after here. So the first step is really dependent on the area of interest. For some prior work that we've done in East Africa, where we lacked kind of cohesive and definite camp boundaries, we actually use Sentinel composites to manually trace out camp polygon boundaries, which you can see in point 1. However, for Cox's Bazar, we can skip this step, as we already have reliable, high-quality spatial boundaries for the camps that we're using as kind of Cox's Bazar, which you have seen on the prior slides. And so the next step is to generate essentially a simulated set of camps, which are going to serve as the reference data set for our analysis. And while it's useful to say, the absolute exposure of camp 35 or whichever camp is X, it's more useful to understand it in the context of the situation of the country or of the region. And so we're using these simulated camps to help build essentially a population of other hypothetical areas where camps could be placed. And then after this, we'll use the Earth Engine system to essentially build a stack of 11 variable rasters. And we use these to actually compute the mean value per camp geometry. So this is per simulated camps and then the actual study locations. After this, we'll review the data structure, perform any imputations or modifications if that's necessary. And then finally, we'll normalize the data at the country level. And after that, we can actually generate the exposure index and percentile for each camp. So we're choosing index variables based on kind of 3 key criteria, and then also removing index variables based on 2 additional ones. So first, we're looking for primarily variables that are included in Google Earth Engine. And this is because it's accessible in kind of a cloud computing environment. It allows us to improve accessibility to our framework and reduce actual computation time. We're also looking for variables that are relevant to our site, to the climate and the geography. So for example, looking at components of wet bulb temperature, landslide triggers, or seasonal rainfall patterns. We're also looking for hazards that have been documented in the camps themselves, and to make sure that our actual index is kind of actually mapping to the lived experience on the ground. And so after we build the initial index and run it over both our simulated and study camps, we then perform a set of additional checks to remove variables that are not relevant. And so first we'll check the distribution of our variables, which we'll explain further in the Colab notebook. What we're looking for is highly correlated variables. And if we find instances of those, we'll want to read through the literature and remove where necessary. And we also analyze from a qualitative perspective, as Jamin had mentioned before, which variables are endogenous versus exogenous. And we want to make sure that, while we might calculate forest loss or additional variables of land cover, we've chosen to remove indicators that could be influenced during camp creation or due to the refugee population from within the camp itself. And this really is aiming to capture variables that are creating enhanced environmental or climatic exposure from outside the camp. And while these have been the focus of other literature, our primary focus is on external exposure. So the following variables here are captured in our index, and you'll see that they originate from a longer list of additional indicators that's in our Colab notebook. And so we've chosen to primarily focus on variables that are relevant to climate, weather, and geophysical conditions. And these indicators range from both pre-computed products, for example, the Oxford Global Friction Surface, to indicators that we've developed ourselves, like the maximum monthly precipitation during the rainy season in Bangladesh. And so while some are geographically broadly applicable, we've also tuned a subset of indicators to the geography of our case study. And we think that this is critical to ensure that we are attempting to reflect to our best ability the actual hazards that refugees face in the camps themselves. If we were going to apply this to another geography, for example, we would recommend retuning the index to reflect the given geography's relevant risks. And as you'll see in the middle column here, the indicators range in spatial scale. And so one of the benefits of using Earth Engine as a computing environment is that we don't need to undergo significant work to ensure that variables are homogeneous in spatial resolution. So all input variables, and here's a set of 3 here, have global coverage, nearly global coverage, and have full coverage across the entire country. And so you can see the varying spatial scales here. And so this is cutting out a portion, one of the southeastern most divisions of Bangladesh. And you'll see that Cox's Bazar is located there in the bottom corner. And we can see already, just based on these 3 here, that relative to the broader region, there's potential aspects of exposure that are high for the camp complex. And this is obviously relevant in the context of this division, but also the broader geography of Bangladesh. And so what we want to do next is then look at the broader context of Bangladesh. And so what we've done here is generated simulated camps that are 1 kilometer in size. And this set of camps we'll use as essentially our population to sample from. One of the choices that we've made here, which is quite geographically specific, is that we've chosen to include all of Bangladesh, given its relatively small scale. But for prior work that we've done in East Africa, where we built similar exposure indices, we used the first 100 kilometers of the border region where we find refugee camps. And so that should be tuned depending on the actual geography. So from now on, we'll use kind of a combination of code snippets and imagery as background to walk through the rest of the index construction. And so this is some Python code, which is using the Earth Engine API. Even if you don't have full, comprehension of the code, it's useful to kind of structure our process as we go through. So in this snippet of code, what we're doing is generating the simulated set of camps by first finding the applicable areas where we can actually generate camps from. And so we're using the JRC Global Surface Water Composites, which are also available in Earth Engine, to create a seasonal water mask. And we're looking for any area where there's more than 1 month of water detected and masking that out. This essentially creates a country level mask of potentially applicable sites that we then use to seed with simulated sites. And so in the next step, we're using that buffer camp to essentially, in this slide, we're using the buffer function that we defined on the prior site as the country level mask. And then we generate essentially X number of camps with 1 kilometer buffers to create our simulated set of camps. These are then exported to an asset, which is also available in our Colab notebook. So after we've identified our sites, we then create a single stack set of rasters. And this is used as the basis for our index. So while you can see here and on prior slides, they vary in spatial extent, we're still able to generate the mean values at each camp level and each simulated site. We do this by using the cat function in Earth Engine. And this essentially allows us to create that raster stack. And each function call, as you'll see here and in the Colab notebook, generates an image, which we then concatenate together. We then use a kind of generic function to process each feature collection. And so the feature collection could either be the simulated sites, or it could be the actual study camps. These are built essentially as tasks in the Earth Engine Python API, which you'll see at the bottom. Because, as we've said before, this is quite time consuming, depending on the scale and the number of input rasters, we've gone ahead and done this before the tutorial. So when we jump into the Colab notebook, we'll start from this point. And so after we process the data, we need to perform some additional checks to ensure that the data are ready for index construction. So we'll do a couple of different things. We'll look for missing observations and gaps at the indicator level. And as we'll see in a moment in the Colab notebook, there are relatively few missing observations. And so we're going to use a quite simplified approach for imputation. But if you use or are working on a more comprehensive set of data where there's larger missing values, there are additional options for imputation, which we outline in the Colab notebook. And so this is partly by design. As we're using globally comprehensive data sets, there's relatively little need for imputation at our sites, but this may vary depending on geography. The other point that we'll go over in the Colab notebook is looking at the variable distribution. So right here we have one example of our input layer. So this is WWF's flow accumulation layer. And you'll see that this is quite varying in scale. And because of this, and this is also outlined in some of their documentation, we've undergone a process known as Windsorization, which is essentially removing extreme outliers. And so we're essentially clipping the data at the 99th percentile. So after we have a set of coherent source data, we will normalize the data to create the index. And we normalize data so that we have a set that we can generate a uniformly distributed index from. Without this step, we wouldn't really be able to say, that flow accumulation or temperature are comparable. And we have quite a range of data, and so this is a necessary process. And so to do this normalization, we use two different functions. We use min-max normalization and max-min normalization. We use the min-max normalization for the majority of indicators. And this essentially allows us to set 0 as the lowest value for that given indicator in the country or population, and 1 as the highest value. The second function, max-min normalization, is used as essentially an inverted version. And this allows us to say that for variables where the lowest value is the worst, and so for example, for surface soil moisture, we use this max-min normalization under the hypothesis that reduced surface soil moisture leads to desertification and lower agricultural yields. For the rest of the variables, we use min-max normalization, and that's more common in the space. And so after we've normalized the data, we perform a simple index rank of each variable and then calculate the percentile of each camp within the distribution of camps. And so this allows us to say, for example, that our index finds that a given camp is in the 90th or the 50th percentile of exposure relative to all other potential camp locations for a given country. And so because we have created the relative exposure in our actual percentiles, we can show relative and absolute exposure for current locations of refugee camps, as well as potential other future locations for camp siting. And so at this stage, we're going to switch over to the Colab notebook and go over some more specifics. And again, because this is not a pure programming tutorial, we'll stay at a higher level, but we're providing the material for students that wish to dive a bit deeper into the process as laid out in the Colab notebook. Okay, and so here we have the Colab notebook. And so as I said before, this is just an interactive Jupyter notebook, and this will be available both in the presentation and at this link here in the agenda. So we have a set of scripts here where we'll go over at a high level, but then we can actually look at some of the data here itself. So first we'll run and import some packages, and then secondly we'll import two functions here that I'll describe in a second. The next step is to actually authenticate with Earth Engine, and so you'll need a Google Earth Engine account or a Google account with Earth Engine access before this step. By running this cell, you'll essentially get a URL displayed below it, and then if you follow the instructions there, you should just paste in your code, and you should have authenticated privileges. So I've already gone ahead and done that, and now we can keep going. So the first step really in our process is to load in the source data. And so we have two functions here that we'll use throughout the process. The first is this get info call, and that's kind of restricted often in the JavaScript environment in the Earth Engine GUI. However, we'll use that to essentially pull data out into the Python environment here. The second are the two functions that I've defined above. This allows us to either generate a map of the feature collection, so for example, a map of Cox's Bazar, or an image here, and you'll see that in a second. So the first step is that we can actually pull in these assets. So this is a feature collection of Cox's Bazar, and then also the border of Bangladesh. By running this, we can actually see here we have Cox's Bazar and its relative position in Bangladesh. So as you can see, it's down here. So now that we have Cox's Bazar exported out into the Python environment, essentially as the GeoJSON, we can then transform that into a pandas data frame. So as you can see here, here's the sub-camps essentially, or the camps of the Cox's Bazar complex. And we have just the first 10 here. So these are various camp names and their actual indices and their area. The next step is that we'll essentially define another set of helper functions and then start showing some indicative rasters. So the first is to get the last date of a given month and year. The next one is to extract a centroid. So we run these two. Then we can get to the actual index construction process. So this is an indicative set of functions, and we have the larger set below linked here. We've chosen two to highlight. So the first is daytime average temperature. The second one is seasonal max precipitation. And while these are relatively straightforward, some are more simple. So for example, the Oxford Global Friction Surface, we're just importing their actual pre-computed index. This is kind of a flavor to show some of the actual more tailor-made indices. And each of these functions, as you'll recall, are actually highlighted on the slides that we've been presenting here. So for this one, we're just pulling out kind of the daytime average max temperature. And the second one, we're pulling out the actual seasonal precipitation max in a monthly term using chirps data. We run these two here. We can then actually set the visualization parameters and render clipped rasters of these two. So the first one we'll run here is for daytime average temperature. And because this is a relatively large layer to load in, it will take a second. And so we can go to the seasonal CRIPS information. So you'll see here is a seasonal precipitation max layer here, which is imposed on the country of Bangladesh and clipped to the border as we described above. And so you can see, as indicated in the slide deck, that this is the same layer, and that we can see down here in kind of the southeastern part of the country that there's relatively high levels of rainfall in terms of monthly maximum rainfall over our time period. And so you'll see here we've now loaded in the temperature, and again we're seeing along this bay elevated temperature levels as well. So the next step we've just pulled out as kind of a code comment, but this is the actual process of actually running the index. And so each of these layers, you'll see that the daytime maximum temperature here was defined and is called. And what we're doing here is we're pulling those functions that we've described above and actually concatenating them into an image stack and then processing the layers as we've described here. And so these go to our asset location, which you could define in your own Earth Engine environment, and then export them just as assets. So after we've actually processed the data, we then get to here. And so this is, as I described in the slide deck, our starting point here. So we're loading in our pre-computed assets, which are here at the EE-ARCET humanitarian environment. So we load these in here. We can then say that we have both the camp data and forest loss data. We've done that because we're doing an average of this, but then the sum at the polygon level for forest loss, as well as our simulated sites, so sample data and sample data forest loss. The first step is actually converting this into our camp data into a pandas data frame, which you can see here. So this is the same as what we've actually outlined above, but now we have actual environmental and climatic information here. The next step is also merging the sample data. And so because of randomly generated index values, we've gone ahead and done a spatial merge for here. This is not actually a final feature of the index, but we've included that for your own information. So we've gone ahead and actually done the spatial join here. And then after that, we can bring in the same. So here's our randomly generated index values. We can bring in the same. So these are our simulated camps and their various exposure indicators, as they're seen here. So these are absolute values, and you can see that there's a large range, and that is the reason why we need to actually perform some normalization. So the last step is to actually concatenate these two together, and now we have our final data frame, which has both our actual camp data as well as our sample data. So the first step in our process is to essentially check for missing data. And so if we do this here, we can see, and if we ignore these more categorical or descriptive stats here about camp name and index, we can see down here that we have some missing values here for specific humidity, surface soil moisture, and subsurface soil moisture. Now, as I described before, we have relatively few missing values. And as you can see, if we're just using these two in our final index, we only have about 11 observations. And so to simplify this process, we've gone ahead and done just mean replacement. But we would definitely recommend, if you had a broader case of missing data, or if you were doing this for an actual decision-making process, you would choose another option for imputation. We go ahead and do this, and then generate our two sets. So here we have the sample variable, which allows us to differentiate between the actual Cox's Bazar camps as well as our simulated set. And so the next step is essentially to analyze our source data and generate our index input variables. And so we won't go into a ton of depth here, but this is available so that you can actually look at the structure of the data itself and begin to understand how we're constructing the index. So if we run this here, we'll generate essentially plotly charts of each of our variables. I zoomed in here. You'll see in the y-axis, we actually have the value or the indicator here. And then here's the distribution of our camp. You'll see in purple we have our study camps, and then in reddish we have our sample camps. And so for each of our variables, we can see the distribution. And what we've done here is kind of use this as a qualitative check. So for example, here's flow accumulation. You can see that we have some extreme outliers here relative to the distribution of the rest of our data. So we've gone ahead and run this for each of the actual indicators, and we use this to examine and see where there are gaps. And so this is running the next set of those indicators. And so the next step is to look for potential correlated values. So for example, surface soil moisture and subsurface soil moisture. And this is already indicated in the literature around these variables, but we can see that there is some slight correlation, but not overwhelming. We can expand on this by building kind of a larger correlation matrix, which I can run here. And this is looking for correlations between all the values. So because we've zoomed in here, it's a little difficult to see, but essentially this is creating correlation matrices of all of our camps at the indicator overlap. So you can see this is coefficient of variation of NDVI and precipitation. And what we've done is gone ahead and looked for any sort of skew in this data, and we would encourage you to also go through to understand that. So after we've gone through our process, we see that essentially 3 variables have some amount of skew, and we've gone the next step, which is to Winsorize these skewed variables. And the primary one that actually ends up in our data set is this flow accumulation. Both forest loss and coefficient of variation of NDVI were excluded because of the exogenous versus endogenous factor that we mentioned earlier. So here we defined a function that actually just clips the data at the 99th percentile. So we'll define that and Winsorize the data. And then we can look at the distribution of the data now, and we can see a slightly better distribution here. And additional work can be done to clip it even further. We think this correctly estimates our data. So the next step is to actually perform normalization. And so these are our kind of initial set. This is our larger list of variables or indicators that we're using. And we're pulling these in and then defining our max-min normalization variables as well. And so we take the Winsorized data and normalize it from 0 to 1. And that's what this process in code is doing here. And so now you'll see that we have normalized our data 0 to 1 across all of our indicators. And so after normalization, we can look again at subsurface soil moisture and surface soil moisture. And we can see that there is a greater correlation here. While there's obviously still some difference, we are choosing essentially to pull subsurface soil moisture to just include and focus on one indicator. So then the final step here is to actually generate the exposure, rank, index, and percentile. And so we do that by generating this function here that quickly calculates the exposure, the rank, and the percentile. And then we generate our kind of subset of our exogenous variables as our index right here. And so now we have, in addition to the actual, let me create this into an interactive notebook, in addition to our coefficient of variation, the actual percentile, which is over here. And so the final step is really about interpreting and understanding the normalized exposure index. So to do that, we could create a box plot here. And this is comparing our study camps and our sample camps. And so we can see a relatively normal distribution of the sample camps, but we can see that the actual study camps here, so Cox's Bazar, are relatively overexposed relative to the population of potential other sites. And in fact, there are some that are quite exposed, almost to the 90th percentile. And so if we just look at the first 10, we could see here that there's a set of camps that are coming out here and that we think, based on our index, have an elevated exposure level relative to the other set of potential locations for camps. And then the last step is that we can run this code to generate our actual exposure curve. And so if we look here, we can see, we have an average exposure of 0.4, but we see that many camps, so these are Cox's Bazar camps here, in these points are relatively overexposed given our distribution and given our kind of set of indices, or given our index. So the last step is to look at primary drivers for exposure. And we've done a part of this, but we're giving this as kind of an additional exercise so you can look into the data itself. So one way to do this is to just filter based on a percentile and then create an interactive notebook. So if you click this button here, you can create an interactive notebook where you can see all of the various indicators, as well as actually sort by percentile here. And so you can see that we have the lowest in here or the highest percentile here. And so then you can manually go through and look for the drivers, or you could programmatically do this as well. And so we can see, for example, that specific humidity is a clear driver nearly at the top of the entire curve. You can see that seasonal precipitation, again, is another driver, as well as surface soil moisture. And so this data set essentially allows us to then dive a bit deeper and probe into additional questions around sensitivity and other kind of drivers of exposure. But this is our first step into the actual index construction. Okay, and so to wrap up, we are now looking at the same data that we've already processed, and this is looking essentially at the spatial distribution of exposure. And we didn't get into this in the CoLab notebook, as it requires a bit of additional work that's outside the scope of this course. But this essentially provides an overview where we can see two primary findings, we think. One is at the country level, we see between kind of the 23.5 to 22 degrees north across the country, we can see that that's relatively overexposed or has a higher exposure level relative to other areas in the country based on our index. And the second point is that the Cox's Bazar complex, which is highlighted in the right figure here, is actually quite split in terms of the amount of exposure. We can see that the northernmost camp has a couple locations that have a very high level of exposure, which is seen in the CoLab notebook. And then some of the more southern camps, or Camp 23, for example, have a lower level of exposure. And so there are some additional questions or additional areas for research here where we can investigate, the primary drivers, how do varying spatial resolutions impact in terms of the actual input data, impact the modeled kind of exposure that we're capturing here. And so we think this is an area for additional research. And so finally, we have the actual kind of exposure curve that we had included in the CoLab notebook. And this mirrors our spatial findings, where we see that there's a divide between the more northern camps and southern camps in terms of their relative exposure. And some of the camps, for example, Camp 4 or the 4 extension, are really highly exposed relative to other potential areas in the country, as well as the Cox's Bazar complex itself. And so we think that additional validation work here to link these exposure levels to other empirical data on hazard events should be really pursued to bolster the confidence in our findings and continue to iterate to improve the actual ability for our index to capture relevant hazards. And so we have some additional last suggestions here around measuring climate exposure in refugee settings. So as we've stated before, there's really a variety of modifications that can be done to the actual index to tailor it to best reflect the geography and regionally relevant hazards and risks, especially the risks or hazards identified by refugees themselves. That's kind of an absent group of stakeholders here. And while Andrew touched on them, I think that a lot of the best potential for this work can come through these interactions where we can continue to improve and iterate with these groups of refugees. We also want to make sure that we validate our results through conversations with camp managers and refugees again, and ensure that we have some level of ground truthing with observed hazard events and other empirical data if possible. And the final piece that we'll add that we'd like to kind of re-emphasize that Andrew was speaking to is that we should really take caution as applied scientists to acknowledge the uncertainties in the input data and the exposure index itself. There's a variety of decision-making points, as we've outlined throughout the process, which could create greater uncertainty or certainty. And we need to make sure that when we actually make decisions around prioritization or deprioritization. We ensure that we take those into account and think through the actual complex set of results that could come out after that. And so we have some additional citations here. And the last step is for questions. So please enter your questions in the Q&A box. We'll be here to answer them in the order they were received. We'll post the Q&A following to the training following the conclusion of the webinar. So thank you.
Thanks, Michael. Wonderful. So just reiterating, please get in touch with Michael, Andrew, or me, or all of us if you have any questions about what we presented here. We are working on a formal study along these lines, so we should be very happy to talk about the work that we're doing and how we're applying it to other refugee camp scenarios. All of our contact info is here. The training webpage permalink is there at the bottom, so please don't hesitate to follow up with the full presentation, to review the Colab coding step by step, and hope to hear from you if you have any questions or have some nice results that you'd like to share. Thanks so much for your attention throughout this part of the training and the training at large. That concludes this NASA ARSET training on humanitarian applications. Thanks again for your interest, and hope to hear from you in the future. Thanks very much.
Yeah, thank you to everybody that have been submitting questions. We do appreciate all questions are welcome. So if you have any and you've been, not the presentation part is over, we do encourage you to submit them to the Q&A box. We do have plenty of time in this Q&A session. So we do encourage you to submit a question if you have one. So jumping into it, question number 1, why Winsorize the data when the top and bottom percentiles may be of most interest, unless bad data, which can be filtered using quality flags in Google Earth Engine? Crops, thermal shock, heat stress, fire hazard, flood hazard are the first perils that come to mind thinking of extreme values.
I can take a stab at this. It's a good question. Michael, I see you're here too, if you want to follow in. I would just say one thing is we're interested in, of course, capturing not just the extreme values for hazards, we want the general trends, right? So of course, if we allow all the extreme values, extreme outliers to come in, some of those may be due to some of the quality issues that the user asks, which is a great point. But we also might just be skewing the index and skewing the actual measurement to some of these more extreme values. So in a sense, that's also why we took mean values over years as well, right? We're not looking at like the worst example year. So it's definitely a different scenario to take the more extreme values. But maybe Michael has some follow-on thoughts too.
Yeah, sure. So I think this really started with the WWF flow accumulation layer, and we found that there were certain kind of pixels where there were really extreme values, and the index got kind of disproportionately skewed because of that, and it almost invalidated the use of that variable. If you have most of the observations in the few thousands, and then all of a sudden there's a pixel, tens or hundreds of thousands, the actual utility of that as an actual variable dropped significantly. And so that was really the primary purpose of the Winsorization.
Great, thank you, Jamin and Michael. Question number 2, is the exposure index a comparative measure among the camps we want to measure, like a ranking?
You guys start, Jamin?
Sure, Michael, take it, yeah.
Yeah, so I think we use it for 2 purposes. The first is, against other hypothetical locations or sites for camps. But within camps, I think we haven't done a lot of analysis, actually within the camp themselves. but I think you could construct something like that because the complex is relatively large in terms of its distance geographically. Some of the variables actually work quite well, but I think once you get kind of the sub-camp level, there are potential questions around the actual quality, the spatial resolution of some of the variables that we're including. And so I don't know, if you were to look at other camps, for example, in East Africa that are relatively small compared to this scale, you couldn't really assess using these indicators and exposure level, within the camp itself.
Great, thank you, Michael. We do have a third question coming in. Thank you so much for those that are submitting them. We do have plenty of time, so if you have a question and you're online, please do submit one. Question number 3, are the Bangladeshi refugee camps large in size because their usage stretches back to 1947 and then again in 1971 and now the Rohingya crisis?
Andrew, do you want to take that one? Are you able to unmute?
Hello?
Yes, we can hear you.
Okay, great. Yeah, sure. So thank you for the question. Glad you asked the question in terms of understanding the size of the camps. I don't think it's accurate to say they're large because of the long drawn out, let's say the protracted elements of the situation there. One of the reasons why I say that is because many of the camps that were smaller in size are actually the ones that have been there the longest. So I think the larger size camps, specifically the one that they call mega camp, which consists of many smaller camps, Kutupalong, it is large because of the influx, the very large number of people moving from Myanmar to Bangladesh in 2017 to 2018. So yeah, I would say it's primarily because of that most recent movement of people.
Wonderful, thank you, Andrew. All right, question number 4. What sources do you use when choosing variables to integrate in the index? What role do locals play in informing about conditions?
Andrew, do you want to take the second part of the question? I could take a stab at the first. So on the first piece, we focused, as you'll see during the presentation, a lot of it was really to find variables that were already included within Earth Engine as assets that we could integrate. Because we wanted this to be relatively adaptable to different contexts, we also wanted this to be globally applicable rasters in many cases. And so that was a main driver. We've done other work where we're including variables that aren't actually sourced from Earth Engine, but I think a lot of the data sets that we've included for our index are quite familiar to folks kind of in the climate vulnerability mapping space. And so, layers like chirps, for example, is a relatively common data set to include. I think when we were trying to capture other forms of exposure, we've had to also look and see what's available within the Earth Engine system itself, kind of their own library, but there are often, we could extend this obviously to include other layers, but that was kind of an internal choice that we've made. But I think, Andrew, you probably have a good grasp on kind of the stakeholder integration in terms of informing conditions on the ground.
Yes, so I think I don't understand the definition of locals here. Is that referring to people that are living around the refugee camps or refugees themselves? So I think it's hard to address that question without additional context.
But you might be able to add that some of the variable selection was informed due to your field work in Cox's Bazar and just intimate knowledge of the kind of hazard profiles.
Yes, that's true. I guess I'm sensing that this question is referring to the role of a certain group of people and how they could inform about conditions. And yeah, maybe the person who wrote this question could elaborate a little bit more in there. I just think the answers would be very different depending on what group of people you're referring to.
Great. With that being said, whoever did pose that question, if you could specify a little bit more about the group that you were targeting when you said locals, and if you can just clarify that in the Q&A box, we will certainly circle back to this question and try to provide an answer for it. Thanks. Looks like some clarification is now coming in. Looks like they mean by locals, I mean people living there that know about the context rather than refugees. So I guess people living within that region, but they're not necessarily refugees.
Thank you for clarifying. I think the best way to answer the question is for the example that, from my experience at least, the conditions have changed to such a significant degree that while it is important to understand the historical, let's say, change over time of conditions in the area, there are scenarios where that information could be somehow not useful and perhaps even misleading, especially when we're talking about the large scale deforestation and terraforming of the land where many of the refugee camps are located. So I don't know the extent to which that the people that have been living in that area, non-refugees, contributed to data collection. However, I think, and whereas I think that type of information would be useful to some extent, I think it's also one of the reasons why we use satellites to get a sense of, the change over time from a consistent, let's say, source. And that's really useful to see the extent to which some of the areas have changed in terms of land cover, in terms of topography, and then subsequently in terms of hydrology and risk of specific hazards.
Great, Andrew, thank you for clarifying the answer for question 4. And it looks like there's a follow-up one. Question 5 is in following up to question 2. If I would be interested in just one camp, would the exposure index be informative, i.e. provide information to identify areas to prioritize help?
I can take a stab at least initially. I think the one question really is, at a sub-camp level, if there's enough spatial resolution for you to actually identify areas where there could be enhanced exposure in the camp itself. And this is kind of getting back to what I was saying earlier, where at a higher level across a country or a region, I think this is much more applicable. I think when you start thinking about within a camp, you can get back to some of Andrew's points around prioritization and deprioritization. And if there's not enough spatial resolution really in all of the layers, then you also need to be cognizant of some of the potential faults in applying this just at a kind of sub-camp level. But if you wanted to say, does one camp situated in a context relative to other locations in the country, then I think it still is applicable. It's just a question of if it's, at the sub-camp level that you're looking for. And so there's also other layers and other variables that you could use to kind of build a subcamp index. This is a little higher level.
I'll also just follow on to that by saying that there's always choices to be made in camp location, and some of those are made in so-called organic or self-settled scenarios where refugees settle new establishment across the border during kind of, immediately during following the initial displacement. But many of these scenarios, including those at least the majority of camps at Cox's Bazar, were planned. That scenario going forward, it's this relative climate index is really valuable in that sense, because we can lay out the potential choices and understand some of which is what the simulated camps are all about. We can lay out some of those potential scenarios to guide future decision making. So the kind we didn't really touch on in the presentation, but some of there's a kind of formalized handbook for site planning and selection, but the kind of data that we're looking at here are not really concerned, are not considered rather in that assessment. And of course they could be. What we're trying to present here is a way of making better use of climate and environmental data to have a very detailed understanding that would allow us to compare the viability of different sites, the hazard profiles of different sites. Would need to do this in every single camp establishment context or camp siting context, but in already risk-prone areas, I think there's a lot of value to doing this. So at that level of sort of like at one camp, that's where that one camp could be. We have a bunch of choices and we can compare them and have a relative index. So future camps, single camp selection could be used in this scenario.
Great, thank you, Jamin and Michael. As
Andrew,
we're waiting, oh, please go ahead, Jamin.
I was just saying, Andrew, I wonder if you have any thoughts, because some of the work that you were doing was a bit closer to the subcamp level work in terms of decision-making frameworks. It might be useful to talk about some of those ideas and kind of decisions, for lack of a better word, that you were using while you were trying to construct how you actually look within the camps themselves.
Yes. So something to add on this front, the work that we were doing was definitely, well, let's say this, the questions that were being asked related to disaster risk management some of them were related to sub-camp level actions. And there were moments when we had to think more about the appropriateness, in downscaling different variables to match what was perceived to be the level of decision making at like the subcamp level, for example. And sometimes, the data, the spatial scales just weren't matching, and I think that is something to highlight. It could be, there are times when the data is not, certain data sets are not appropriate to integrate into decision making, and sometimes it's due to spatial scales that don't match the decision making context. Sometimes it has to do, if you're looking at forecasts, just like lead time doesn't match with the amount of lead time that's needed to take action in either one camp or multiple camps. But again, I think this is where a lot of our work was in identifying what questions were being asked related to disaster risk management, and then also, like what actions could be taken. How do you justify taking actions using different data? How do you prioritize certain camps and sub-camp areas? And then on the other hand, how do you deprioritize when everyone is the most vulnerable by definition? So I think just going back to that point is important to highlight here.
Again, we have just over 20 minutes. We do encourage if anybody out there that's online, if they have a question, there are no bad questions. We encourage them. So please, if there is one you want to ask this excellent panel of presenters that we have for you today, please do submit it in the Q&A box. Another thing I would like to highlight as we're waiting for other questions to come in is the homework is now live on the training page. If you go to the training page and scroll down underneath part 4, there is a link to the homework. That homework is inclusive of all 4 parts of this webinar series. And so we do encourage you, you have until, I believe it's July 5th, to complete and submit that homework based upon the today's presentation as well as the first 3 parts of the presentation. So we do hope that you will access that and start working on the homework. And one other thing I would like to make you aware of is after the conclusion of this webinar series, you will all be receiving in your inbox, in your emails, a survey that will be sent with a list of questions. It will not take that long to complete. It typically takes around 5 minutes, but we do hope, we strongly encourage that everybody please do take the time, the 5 minutes it takes to complete that survey and submit it so that we as a program, RSET, as well as all the presenters, can get the feedback from you on what worked, what didn't work, what you would like to see changed going forward, as well as suggestions that you have for future RSET trainings within this application area of humanitarian applications. So please do, you should be receiving that survey probably by early next week. And we do hope that you all take the 5 minutes it will take to complete it. Thank you. Great, thank you for whoever just submitted this question. Question number 6, how different is the indexing approach used here from the analytical hierarchy approach? Which one gives a better susceptibility outcome?
I can take a stab at that. We didn't consider the analytical hierarchy approach. We haven't run as a comparison. That's a good suggestion. So that AHP approach takes basically takes a different kind of weighting scheme where you explicitly describe the magnitude of the importance. You have different weights that are scaled with respect to each other. So you could have one category of concerns that are each collectively represent a sort of a quarter of the overall weight, and you may have another category of concerns that collectively represent an eighth of the overall weight. And that analytical, that hierarchy then allows you to subdivide and general themes of concern in our case, and then look at all the variables that make up that theme of concern. And for example, you could uniformly weight them within each category, but then that category itself only represents a quarter of the total concern, or you could say the contribution to the index is really what that would translate to. That's a really nice way to do it. We, in this case, didn't certainly could take that approach. We only really have these two high level categories, geophysical and then climate and environment. So we didn't take that approach. Could certainly do that. We also, just to be concrete about it, we uniformly weighted all of our variables. Different sensitivity analyses could be undertaken, or certainly adapting this kind of approach in different contexts. That may see different variables brought in. It also may see different weighting of these different variables. Going back to the earlier question, how do you even assign those weights? That's tough to do, sort of outside of a scenario where you test and gauge the impact of the inclusion of these different variables in the index, both in terms of the sensitivity of the climate exposure index, as well as the priorities identified by in our scenario, refugees and camp managers living in Cox's Bazar. So with additional data, I think you could have a more nuanced weighting scheme, but in this presentation, we're just sort of giving the nuts and bolts, I guess, of this and introducing this idea, which hopefully has some flexibility so that you could certainly adapt this AHP approach that doesn't change the fact that you're doing an index, it just changes how you basically would undertake the weighting scheme and how you conceptualize the contributions of different variables to that exposure.
Yeah, I guess the only other thought that I would add is that there's often, we've found there's not enough empirical data for us to test and really categorize and quantify the actual hazard events at a large enough scale that we could, I think, feel informed enough to create a different weighting scheme. And so that's why we've really taken the uniform weighting approach. But I think in other scenarios or other contexts, it is definitely feasible and something that should be considered. We did some sensitivity tests for these locations here, and then also some of our other work in East Africa, just using variable replacement. And we found that the actual exposure index is relatively robust to that, but there's obviously many other ways that you can construct this. And I think, as Jamie was highlighting, this is a framework for thinking through how you would assess exposure, maybe not necessarily a one-size-fits-all approach.
Great, thank you, Michael and Jamin. The next question is for Andrew, and it looks like it is from somebody who is working within the humanitarian sector. Andrew, you mentioned the high number of products available in Cox's Bazar context. Would you say that most of them were just not used? As the humanitarian sector worker, I know the amount of information available, usually a little relevant and definitely not used. How do I focus on what actually can be useful? How do I avoid this overproduction of underused reports and assessments?
So thanks for the question. I'm glad that you're highlighting some of these questions from a decision maker perspective. I should say, I mean, this is surprisingly to me, this has become a significant part of my work, to act as kind of like a broker or a translator between the humanitarian decision-making world, humanitarian sector more broadly, I'd say, but specifically for decision-making on the ground, and like the climate science, Earth observation community. And there's no real, I'd say, simple answer here. I think a lot of this a lot of the best practices around identifying what data is useful can be broken down to building relationships with the developers and disseminators of the information. Another key point when to say no thank you. I mean, sometimes it's hard to say that we don't necessarily need another product, but I think that could be really powerful and would lead the developer of that data or data derived product to think more about what does it mean to think you're helping necessarily. I mean, I think normalizing the discussion around like, well, the data actually wasn't that useful and could have potentially made things a little bit more complicated. I've definitely been in situations where that was the case. And as you know, as a humanitarian worker, you have to make a decision, and many times there could be too much data in too little time. So thinking about questions like, is the data available sufficient? Is the data available ideal? And is the data available actually making things more complicated? Like, these sorts of questions I think are important to process. And I would say the more that you have relationships, not only with the developers of the data, but also with people that kind of operate between the spaces. That will increase the chance of, let's say, more efficient filtering of what data could be useful and perhaps could not be useful, and also allowing for stronger relationships between the people developing the data, disseminating it, and then yourselves and your team. We do have, maybe this is a time to share a recent paper on this topic that a colleague and I published, talking more about like the questions and the roles and responsibilities operating as you're operating between the climate data space and the humanitarian decision-making space. So I don't know where the best place to place the link. Would it be in the Google Doc here, or would it be in the chat here?
Right into the Google Doc, Andrew, if you would, right under question 7, if you can just put that link right in there.
Okay. Yeah, this paper has some, I mean, it's an academic paper, so it's not really written in a way that is intending to, let's say, develop standard operating procedures necessarily, but it is a reflection on the need for this type of work. You know, not only producing tools or producing interfaces and hoping it helps, but talking about the roles and responsibilities on both sides. You know, the more responsibility has to be placed on data scientists and climate scientists for sure, but then it also speaks to the need for perhaps additional training and enhancing the knowledge, baseline knowledge at least, around climate data and risk data for the humanitarian sector. But yeah, the paper was meant to kind of enhance this discussion, and it's definitely a place to think more about what does it mean to integrate climate and risk data into decision making, and when it is and when it may not be kind of as easy and as useful as we all think. So, but I'm also glad to talk more about this. It's something that has really become a big part of my work over the past 5-6 years. So feel free to reach out over email, which is I think somewhere maybe on the top of this document. Yeah. So yeah. Thank you.
Yeah, Andrew, it's so great that you're able to contextualize all this with your background in remote sensing science, but also your work within the sector, both on the ground, working directly with decision makers. It's just, yeah, very valuable having you part of this presentation. And Andrew's email contact is both within the slides that are currently on the webpage, the contact information, as well as on this Q&A document. So yeah, please, I think all of the presenters have encouraged you to reach out if you have any follow-ups. Question number 8, what was your experience with the final users of the results of this research?
So I guess I would probably punt this again to Andrew, because this is still something that we're working on and developing. It's more of an academic approach than Andrew's, and I feel like you have a better amount of context that you can share, Andrew, in terms of the actual results of your work in Cox's Bazar, because this is still, you know, in development.
Yes, so I will say that some of the outputs of our work led to a better understanding of landslide risk, you know, baseline landslide risk, and then also thinking about what could an anticipatory action system look like related to landslides. So I'm not sure of the current status actually, just because this project was a few years ago now, but yes, to answer your question directly, it led to an improved understanding of landslide risk, and also the ability to understand what actions can be taken to decrease risk of landslides in the Cox's Bazar area.
Great, thank you, Andrew and Michael. Question number 9. In your opinion, confusing radar images into pan-sharpened optical data deduct the urban sprawl area outside the metropolitan cities?
I can take a stab at this. A little bit outside the scope of this part of the training, but if you're interested in urban sprawl, pan sharpening suggests that you're probably working with Landsat data, and you're interested in going from 30 meter down to 15 meter data. You probably don't need pan sharpening if you're going after urban sprawl, because urban sprawl takes place at scales that are well beyond that sort of 15 meter scale. It depends on the city, but you probably are okay with a moderate resolution system to do this. You don't need to map a city at 1 meter resolution, for example, to detect urban sprawl. Radar data, if you're referring to synthetic aperture radar, like we worked on in part 1, that also has a 10 meter nominal resolution. So certainly there's interesting opportunities, valuable opportunities for fusing radar scatter data with optical data on reflectance and texture. Yep, that definitely would be helpful. Some of that I think just is depending on the timing of the urban sprawl, right? We only have radar for the past, SAR at least, imaging radar, widely available for the past 7 years. So, 7 years of sprawl, that may not be sufficient. You may need to be going into more of the Landsat record, or even the, MODIS could be effective, daily 250 meter coverage. So yeah, lots of valuable things to do there. That kind of work that's done globally right now by, say, the Global Human Settlement Layer, or the Global Urban Footprint, or World Settlement Footprint, actually the up-to-date version of the Global Urban Footprint. Those do integrate satellite radar data into their optical assessments. I think the story is still kind of driven by the optical data, but the radar certainly has something to say. Yep, it correlates in some ways with what we see optically, but it does pick up obviously very different features, different kind of textural sensitivities, and it has a different kind of sensitivity to infrastructure and change as well that we don't have with optical data. So yeah, very complementary approaches.
Thanks, Jamin. It does appear that the questions are slowly coming to an end. I haven't seen any new questions added, so I do think that just because we are getting close to the top of the hour, I think it's appropriate to maybe wrap up a little bit early. I want to thank everybody that attended today. I know that this has been a 4-part webinar series. You certainly have busy lives, and there's many other things you could be doing with your time. And the fact that you chose it to learn about different humanitarian applications using remote sensing and model data is one, it's very important, and 2, we hope you certainly got a lot of value out of attending these trainings. So thank you to everybody that attended. I also want to thank our guest presenters today. That's Jamin Vandenhoek, Andrew Krukowitz, and Michael Owen. And we want to thank all of them for joining us today. And before we close, I wanted to give them an opportunity to provide any closing thoughts or comments on today's training. So Jamin, over to you.
Thanks, Sean. Really appreciate you really spearheading the organization of this 4-part series. And thanks so much to Selwyn for helping us record and tightening up these presentations as well. Yeah, just thanks to all the people in attendance here today that have joined, at least today, and hopefully more than today. Please don't hesitate to reach out. Any questions you have about the work we've done or presented, or if you run through some of the code, or the whether it's on Earth Engine, or working with the Vertex tool from Training 1, or working with the Colab from this part, any issues at all, please get in touch. I really appreciate the interest in RSED and setting this up in the first place, the humanitarian applications, and I really want to give a big thanks to Michael and Andrew for contributing so profoundly to this study that this work that we shared here in this part, and also the presentation today. Thanks, everyone, and I guess over to Michael.
Yeah, I just echo everything that Jamin just said, but thank you, everyone, and please don't hesitate to reach out to me. Andrew, over to you.
Thank you, everyone, and thank you for everyone who asked questions. Yeah, nothing really to add, but very glad that we had the space for this. So thanks to NASA ARSET for allowing this space to exist. And yes, this is, I guess one final thought I'll comment I'll make is if there are people attending here that are kind of interested in this type of work, you know, integrating climate and Earth observation data into humanitarian applications, this is definitely a growing community, and there is a need for people to step into this space. I would say even 10 years ago, it was a different type of career path, but yeah. So if anyone's in that position, either in school or just maybe interested in a pivot in career, like there's definitely opportunities here. So feel free to reach out, and glad to discuss more about that.
Wonderful. I also want to thank the ARSET team that you might not have heard during this webinar series, but they've certainly been working very hard in the background to make this a successful webinar series. That's Selwyn Hudson-Odoi, Brock Blevins, Jonathan O'Brien, Sarah Cutchell, and Amita Mekta. So thank you to the ARSET team for helping support this training. Again, thank you to our three wonderful presenters, Jamin, Michael, and Andrew. And thank you to everybody joining. The homework is up. It's due on July 7th, so please do take advantage of that. And then also the survey that will be sent out next week. Please do fill that out because it helps all of our future ARSET trainings to improve on them. So again, everybody, please stay safe, and thank you again for joining. Bye-bye.